Okay, this is lesson 13, part 2. So part 2 is going to be pages 7 through 12, and that's section D and E. So we're doing sections D and E. So we're talking about equivalent fractions. So just as we reviewed for the last 10 minutes, we talked about proper, improper, and mixed and converting back and forth. Now we're going to talk about our final answers. Final answers in a final answer question must be reduced always. So we're going to make a big note here that says always reduce fractions. Okay, so we're going to always reduce fractions in the final answer. Okay, so you don't do it till the final answer. Okay. So our first example says we want to make equivalent fractions. So we want to show the same amount. So if I'm showing you, first of all, we have the shape. This shape is, first of all, a square. Okay, so we have two different shapes here. We've got a square, and then we cut the square in half and made triangles. So this shape has two parts. It's saying one part shaded, one part is not. So we talked about the shaded and unshaded yesterday. So we have one shaded part. We put our shaded on top and our total number on the bottom. Total number of pieces. Okay? So now that we've got our total number of pieces, he's back, perfect. Okay, in A, it's showing us now what are we going to represent? Look at the bigger picture. If I have a bigger picture, here's a new situation. I've got 1, 2, 3 parts. There's my 3 parts shaded. Okay, there's my 3 parts shaded. And then I've got 3 parts that are not shaded. So how many parts total? I've got 6 different parts. So I've got a 6 or a 3 out of 6 are shaded. Now, why is it saying 1 out of 2 is also the same as that answer? Well, what if I had all of this together? What if I got rid of that line and got rid of that line and made this one big giant rectangle? Same with this one. What if I made it one big giant rectangle? That would mean you would have 1 part out of 2 that is shaded. Okay? So that means you would shade this whole part, and that would be equal to 1 part shaded out of 2 full parts. So you can divide your objects in different shapes and into different sizes. So let's take a look at a number line. How do they do it with number lines? Well, you want to look at the bottom. You want to compare the bottoms so that the bottoms are the same number when you compare them. So they have different numbers on top, same number on the bottom. So when we compare them, who's bigger and smaller? We did that yesterday. If the bottom number is the same, all we got to do is look at the top. So we know this guy has more parts, so this guy is bigger. Okay, he's a bigger number. Now, if I look at how many spaces are between the 0 and the 1, right here I've got 1, 2 spaces total. 2 spaces total between the numbers. That number becomes your bottom number. That becomes your 2. So that number becomes the bottom. This one has 4 spaces between. So since it has 4 spaces between, that means it's going to have a bottom number. That means, so I'm saying equals, the bottom number equals a 4. That's why. So whatever amount of pieces you divide your object into, that's the total number on the bottom of your fraction. So let's take a look at these pies that we have here. It says pumpkin pie is Dave's favorite pie. Would he rather have 1/2 or 2/6? Or sorry, 1/3 or 2/6? Well, let's take a look at what he divided his pie into. Well, here he cut into 3 pieces. So he cut into 3 pieces. So if he takes that one, the white one, if he takes the white one out, So what would he have? He had 2 that he has left over. So this can be for someone else and this can be for someone else. But he ate one big giant piece. But look what happened on the other object. What did they do to each of those pieces? They cut each of these pieces in half. They chopped them in half. And that's what became this one. And then we got a total number of 6 pieces. So if you can divide an object into an equal amount of pieces, then you've got an equivalent fraction. You can't take it and make a different amount of pieces. For example, if I've got a circle and I say I want to divide it into, I start with 3 like we did, and I'm going to say now to you, divide it into 7. You wouldn't be able to divide that into 7 equally with only 3 pieces showing. Because if I divided this guy in half now, I get 6 pieces, and they should all be the same. But how would I get a 7th piece in there? You would have to start over at the beginning without it divided already. So you would start with a blank circle, and then you would start cutting your pieces. Usually it's an even number of pieces that they cut into, okay? So pies, pizzas, they're usually an even number on the bottom. Okay, usually an even number on the bottom. Now, does it always work that way? No, because we see on this first object, they divided it into 3, and 3 is not an even number. So does it always have to be an even number? No, you could divide it into different numbers, but they have to be the same size. I wouldn't be able to take this object and say, okay, I'm going to divide this one. I wouldn't be able to say divide this guy into 3 or 4 and then divide him into 1. That's not correct because they're divided into different amounts. They'd have to be the identical amount each time. Okay? All right, turn your page. So it says identifying using multiplication. So to find out if they are equivalent, you take top, divide, bottom, and the decimals must match. The decimal answers must match. Whoops, not a C, an S. Must match. Okay, so the decimal answers have to match. Okay, so if I take 2, divide 6, if I go 2, divide 6, I'm going to get 0.3 repeating. That's my decimal. Now if I look at 6 over 18, if I divide them, I'm going to get 0.3 repeating. They're identical decimals. That means they're equivalent fractions. So how can we make equivalent fractions if we only have 1 to start with? So this guy here is saying, I'm only starting with the number 2 over 6. This guy's only starting with the number 4 over 5. This one is only starting with the number 3 over 4. Okay? So we start with one number. If we want to create an equivalent fraction, whatever we do to the top, we've got to do to the bottom. So they're showing here, they times them both by 3. That works. You could pick any number. You could times them both by 10. You could times them both by 2. Typically, they try 2 and 3. You try to do small numbers so that you're not dealing with too large of numbers. Here they chose the number 4. Here they chose the number 7. As long as you're doing it to both the top and the bottom, you will create an identical fraction, meaning their decimal answers will match. And that's what you always have to make sure. The decimal answers match. That means you did the question correctly. So let's take a look. That's with multiplying. Here's another example. So we're going to go example D. So if I've got the number, let's go with 4 over 9. And I want to make an equivalent fraction. Well, I'm going to choose any number. It doesn't matter what number I want to choose. Somebody shout me out a number.
6.
All right, 6. Hey. So, oh yeah, of course. So we're going to times this guy by 6. And if I do it to the top, I'm doing it to the bottom. So I'm going to do it to both numbers. So then this one becomes a 24 over 54. And now if I check my work, both decimal answers are going to match. This guy's going to give me 0.4 repeating. This guy's going to give me 0.4 repeating. That means I match them. They did it properly, okay? If they match, you did it properly. So we can do it by multiplying by a number. And then we're seeing we can also do it by dividing by a number. So if we've got a bigger number that we start with, so if we look at the first couple examples, those numbers are small. 2 and 6, 4 and 5, 3 and 4. Those are single digit numbers. If I move into double digit numbers on the bottom, I can start dividing, especially if the numbers are even. So we have to remember our dividing rules. Okay, we have to remember our division rules. So, even numbers. What do we start dividing even numbers by? What do you think? Who remembers? What do you start dividing even numbers by? 2. Good. So, we divide by 2. And if that doesn't work, then we move to the next even number. Then we go to 4, then 6, then 8. We always start with the smallest. Start with 2. If they're both even, they should divide by 2. If it's an odd number, what number should we start dividing by? 3. Good job. So we would start dividing by 3. What if 3 gave us a decimal and didn't work? Then we go to 5, the next odd number. Excellent. And what if 5 doesn't work? Then 7. Excellent. And we just keep going up the rule as odd numbers. So what if 7 didn't work? Yes, you'd go to 9, then 11, etc. And you'd try to find the number that divides evenly without giving you a decimal. That's how you know it works. When I say it works, that's what I mean. There's no decimal answer. Okay, so they're showing us all of these. These guys are both even, so they started dividing by 2. Whenever you've got one number even and one number odd, that's when you have to go with odd number division. So if both numbers are even, divide by 2. Both numbers are odd, divide by 3. If you've got one of each, an even and an odd, you can't go with even numbers. You got to start with the odd numbers. So this guy has an odd on top and an even on the bottom. When they don't match like that, they're not the same, you start dividing by 3. So that's why they chose 3. You always start with 3. Okay? And if 3 didn't work, what would I do?
6.
Oh, what's the next odd number?
8.
I would go then to my odd number list. You'd go to your odd number list. So count every 2 numbers. 3, add 2,
6.
then 5,
9.
add 2, 7, add 2, 9, add 2, 11. So that's the numbers we start dividing by in order. Yes. Put your name on the list. Okay. So again, both these numbers are even on letter C. So they chose a larger number to divide by. But again, it's an even number. If they chose a smaller number, they would have just had to divide a couple times. And that's okay. All right, let's take a look at page 9. Okay, back to this, part D. We are still using equivalents. So to make equivalent fractions, we can identify numbers by using multiples. So we would use the bottom numbers. So we're going to try the bottom numbers here, 3 and 4. So we're going to make multiples of 3 and 4. To make your multiples, remember, you are skip counting. Okay? You are either skip counting or multiplying. Okay, so or multiplying. And then you find the number they have the same. So identify the multiples of 3 and 4. So I would go 3, add 3 more, 6, add 3 more, 9, add 3 more. Okay, same thing with the number 4. I would go 4, add 4 more, 8, add 4 more, 12, add 4 more. So that's your skip counting. Now we're trying to look for a number they have the same. Well, then what number do they have the same here, folks? 12. We would loop and circle the one that they have identical. So they're saying, and they're telling us, quiet please, they're telling us that our lowest common multiple is a 12. So that means I can make the bottom number of 12 and cross multiply. So we are going to do this. We're setting up a cross multiply situation. That's what we're doing. So you set up a cross multiply situation. Okay, so now we've got cross multiply. We're solving for the unknown number. So if we look up here, my x would be on top. My x is on top. So when I do that, I'm going to loop the two that if you're going to look diagonally, where do you have two numbers diagonally, not the missing number, where you've got two numbers diagonal? That's
Horizontal.
Diagonal is not horizontal. You're going to look diagonal and you're going to multiply them. So that's why it's called cross multiply. You're going to multiply those two numbers and then divide by the number left over. The number left over sometimes is on top. We're focusing. So we're cross multiplying and dividing. When I cross multiply and divide, I'm going to get 8. Okay, so 2 times 12 is 24. 24 divided by 3 gives me my 8. So there's my top number of my fraction. Now, you could also think of it this way. You could go 2 over 3 equals something over 12. My equal sign always looks like a not equal. Okay, equals. So now what you do is you find out the missing number. You would say to yourself, okay, 3 times what gave me 12? And you try to find that out. So you would work backwards. So what's the opposite of timesing? What's the opposite of timesing? Dividing. That's okay. So we would take 12 divide 3, we would get 4. So that means I times the bottom by 4. And we know with fractions, whatever I do to one of them, if it's the bottom, if I do something to him, I got to do it to the top. So that means I'm going to times the top by 4 as well. So that's how I get my 8 on top. So there's a couple different ways we can do it. We can set up the cross multiply, or we can work backwards. We could say 12 divide 3 gives me my 4, and that would be my missing number to multiply by. So my 4 would be this number that I'm multiplying by to get the new missing number. So I would take my 2 times a 4 and get my 8. Okay? So they would do the same thing on this one. 4 times 1 is 12, 4 times 3. So they're multiplying 1 times 3 right here, giving you your unknown number of 3. Okay? Now it says add your equivalent fractions. So I made an equivalent fraction, 8 out of 12, 3 out of 12. How much would it get altogether? Well, if it's all out of 12, you're going to add the top numbers. Okay? All right, turn your page. We're doing the same thing with the number 6 and 8. We are almost done, folks. We're doing the same thing with the numbers 6 and 8. So you find your multiples, and we find the numbers that they go into. So this is going to become something plus something. We found the number that they have the same is 24. Whoa, there we go. It moved on me. So since 24 is my number, that becomes my new bottom number. Yeah. So I have a 24 here. And now what we have to do is we have to say, okay, 6 times what gave me 24? So you can work backwards too. You could say 8 times what gave me 24? Well, 8 times 3 gave me 24. So I need to times your top by 3. Over here, 6 I times by 4 to get 24. So I would times my top by 4. Okay? That's going to give me a 9 on top and a 16. So we get our 9 and our 16 on top. That's what they're showing us right here. We get our 9 and 16. Now we're going to add them up. If I add those 9 and 16, I'm going to get a 25. Well, that means I have more pieces than the bottom. When you have more pieces than the bottom, you've got an improper fraction like we talked about at the beginning. So now this is our improper fraction, that one. So this guy is our improper. And this guy is our mixed number. So this is telling us that we had 2 pizzas, both cut into 24 pieces. I ate one full pizza, and then I've got one piece from the other one I ate. How many would be left over on that pizza? How many other pieces? If I ate one of them, how many are left?
4.
How many are left in the fridge? Well, take a look. It's cut into how many pieces? 24 pieces. And if I eat one of them, how much is left over? 23. So there's 23 pieces left over. Okay, now we're going to talk about our last section, reducing. So reducing fractions is always a must, okay? So when we reduce, just like we were finding lowest common multiples, whatever we do to the top number, we have to do to the bottom number. So we're either timesing or we're dividing. In this case, it's usually always dividing. So we're taking a big number and we're making it smaller, but we have to divide the top and the bottom by the same number. And this is where we use our division rules that we remember. So if it's even, we divide them both by 2. If they're odd, we divide them both by 3. If one of them ends in a 5, we try dividing by 5s. If they end in zeros, we divide by 10s. Okay, but they have to both end in 0 for that. These ones are even numbers. So this guy here and this guy here, they're both even. So they started with the number 2. Then we got another even number and another even number. They could have done a 2 again. They did 3 instead, but they could have done 2. Okay, this one you had both even numbers, one ending in a 0. If you only have one ending in a 0, you can't divide by 10s. They have to both end in zeros. So this one, again, you could divide by 3 if you know they divide by 3, but because they're even, you should have started with 2. So 2 would work as well. So if I had 24 over 30, because they're even, I would have started with 2. But look what happens. That'll give me a 12 over 15. Now I've got one number even, one number odd. That means I have to start dividing by my odd number, which is 3. And that's going to give me the same answer, 4 out of 5. So no matter how I do it, I'm still going to get this same answer of 4 out of 5. As long as you're dividing by the same thing on top and same thing on the bottom. And remember, you have to divide so it doesn't give you a decimal. That's how you know it works. All right, turn your page. Using greatest common factors. So again, all this is dividing by numbers that are larger, so you don't have to reduce for taking. Sometimes reducing can take you like a full page. So what you want to do is you want to maybe make a factor list and see what they have in common. So for example, 21 and 28, they're big numbers. So I could make a factor list, and this is our factor T-chart. So I would say 21, and then I would go 1 times 21. It's odd, so it won't divide by 2, so I would divide by 3. I get 7. Now whenever you get to this part, you have to look at the numbers in between these two numbers. I have a 4, a 5, and a 6. So you try dividing your 21 by those numbers to see if it gives you decimals or no decimals. Those ones give us decimal answers, which means they don't work. So that's why they used all 4 of these numbers right here. So you've got all 4 numbers. They did the same thing for the number 28. They did a factor chart, and you got 1 times 28, 2 times 14, and 4 times 7. The number 3 won't work because it's even. It'll give me a decimal. And now I look at the numbers between 4 and 7, 5 and 6. If I try dividing by 5 and 6, I get decimals. That's supposed to be a 5. So if I divide by 5 and 6, I get decimals, which means it doesn't work. So that means these are the only numbers that divide into 28. So again, they made the list right here below. Now, once we've got the list, now we circle which ones they have the same. So I'm going to take a look, and now I'm going to circle the ones they have same top and bottom. Every number should have the number 1. The number 1, everybody has the same. Okay, we don't consider that a factor because remember, 1 is not prime. So then we look at the next number that's the same. Oh boy, I see a 7. There's no other numbers. So if you find no numbers in the list except a 1, you say they have no common factors. This one has a common factor of 7. So what did they do? They divided it both by 7, and then they got their answer quicker. So when you do a factor chart and you divide by the largest number, that will give you less work to do. Okay, it looks like a lot of work by doing a factor chart, but it's actually less work than divide by 2, divide by 2, divide by 2. Oh, it's an odd number now. Divide by 3, divide by 3. Okay, so that takes a long time when you're doing it. So this way speeds it up and makes less work for you. Okay. All right, so we're going to reduce to lowest terms. We always have calculators, so I don't expect you to do it without one. We always have calculators. So on this one, we could do it by dividing. We would get, they're turning these numbers into mixed. So we are convert to mixed is what they're doing. So I've converted this guy to a mixed number. All you're doing is taking top divide bottom. That's how you convert to mixed. Same thing here, top divide bottom. But I have no remainders. Here I'm going to get a 24. I subtract and I get 0. When you get 0 remainders, that means that your answer is just a whole number. There's no more fractions. Okay, the fraction's gone. Now, can you make any whole number into a fraction? Oh, yes, we can by going over 1. Okay. Does it have to be in a fraction if it's like that? No. You can leave it just as a whole number. Okay. Turn your page, please. Page 12. It's just the top of page 12. Mine's not working, but I'm going to show you what they have on the page. So A says 6 and 1/2. Adding 1 and 1/2. So we're going to add the whole numbers. So these we are going to add together. That's going to give me a 7. Now we're going to add my fractions. Well, my fractions say I've got 2 fractions. I ate half of a pizza, and this guy ate half of a pizza. If I shaded those on one object, what would happen? So if I wanted to shade this on one object, I said, okay, this one's going here, this one's going here. What would you notice? What do you notice?
The pizza's gone.
The whole pizza has been eaten. You've got another whole pizza gone. So that means this is one whole. So 2 halves make one whole. So you're going to have 7 plus 1, which gives us 8 wholes. Okay, so we get 8 whole. On B, we've got 2 and 4 over 5, adding 3 over 5. So there's no big numbers to add because 2 has nothing to add to in front of this guy. There's nothing there. So that means my whole number is just going to be a 2. Now, the bottom number of your fraction is the same. So again, I'm going to make a rectangle because I've got 5 pieces. So I'm going to make a rectangle because it's easier. Whoa, glitch, glitch, glitch. Okay. So if I go 1, 2, 3, 4, 5, and I shade 4 of them on this one, and then on the other guy, I've got the same thing. I've got 5, and I shade 3 of them. How much is that going to be on one object? So if I need to shade one object, how much is going to be shaded?
30%.
So if I need to put this all on one object and then the leftovers, I'm going to shade these four. 1, 2, 3, 4. I've shaded those guys. Now I'm going to shade these. 1, 2, 3. So this gives me one whole, and this tells me my leftovers. So sometimes it's easier to draw a diagram. So right now we've got leftovers. So that means I have to add one whole, plus I got to add my leftovers. My leftovers is a fraction of 2 shaded out of 5. So I have 2 shaded out of 5. So that's going to give me 3 wholes and then 2 shaded out of 5 in the end. That's how we're going to get our final answer. Okay? Letter C works the same way. You're going to draw your diagram on letter C, only letter C is going to have your diagram divided into 9 parts. There, hang on.
Why is the whiteboard thingy so blurry?
I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretend they're the same size. Okay, so for letter C, you would draw your diagram, and then you would shade how many, and you draw 2 of those that have 9 pieces, and then you'd shade how many you need. And that's going to tell you how to create your final answer. This concludes reducing and making equivalent fractions.